Hi, everybody. Welcome to the self-check section 10.4 video. Let's go ahead and take a look at number one. So number one states a study was conducted to investigate how effective a new diet was in lowering cholesterol. Results for the randomly selected subjects are provided in the table. The differences have a normal distribution. And so here's an important question. Are these subjects' cholesterol levels lower on average after the diet? So after the diet, are the cholesterol levels lower? And we have a 5% significance level, so alpha is 0.05. Okay, so we have this table here of subjects A through I. Before and after they take the diet pills, and their cholesterol levels are given as the numbers. So first thing we want to do is to pick in L1 and L2 to put into our list. So what we're going to do here is have before be L1 and after be L2. So, that being said, we want to see if the cholesterol levels are lower after the diet. So when we create a list three, because we need to create a list three, let's go ahead and choose just L1 minus L2. Let's follow this path. Okay, when we create a list three, we need to subtract the two lists, the difference. So if L1 is before and L2 is after, and we want to know if the cholesterol levels are lower after the diet, that means after is going to have a smaller number. So that means a bigger number minus a smaller number is going to be a positive number, which means our inequality is greater than 0. So that means our hypothesis is going to be null alternative. Our alternative hypothesis is going to be mean difference greater than 0, and that is our claim. Okay, and that means our null is less than or equal to 0. Okay, great. So here is our hypothesis set up, and now we need to go ahead and run our test. So calculator work. Remember we use t-test. So let's go to t-test and see exactly what we need. So before we even do that, we need to create our list three. So what I did is I went ahead and entered in the data for list one and list two. So take a minute and enter in that data and come right back. Okay, welcome back. So hopefully you entered in the data for list one and list one being before, list two being after the diet. All right, so we need to create a list three, and what we said to construct our hypothesis was L1 minus L2. So what you need to do is click on L3, highlight, make sure it's pink, press second L1 minus second L2. And that's what you should get. So you generated a whole new L3. So we're going to use this L3, that's our new sample, that's our new data, and we're going to run a hypothesis test with it. So we need to go to t-test, and our mu naught is 0. That's our number in our hypothesis test. We need to change our list to list 3. So second 3, and our inequality is greater than. So we move to the right and select greater than. So we hit calculate, and this is what we come up with. A test statistic of 2.73 and a p-value of 0.0130. So let's write down our calculator work and our results. So we get data 0, list 3, 1, and greater than. And what we got was t equals 2.73, and the p-value was 0.013 and 0. All right, so conclusion about the null, that's where we compare the p-value and the alpha. So our p-value was 0.0130. Our alpha was 0.05. And so our alpha is bigger, which means we reject the null. So we reject the null, and let's write a final conclusion that addresses the claim. So do we have equality in claim? No, our claim is greater than, so no equality. So no equality in claim, and we reject the null. So pull out your conclusion table and try to write a conclusion. I'll pause the video and compare what you got to what I wrote. Okay, welcome back. So hopefully you have the same conclusion that there is sufficient evidence to support the claim that the subject's cholesterol levels lower on average after the diet. Okay, so this is what our hypothesis test is telling us. So now we have to construct a confidence interval to verify that our hypothesis test is telling us the right thing. So construct an appropriate confidence level. As always, we need to get our confidence level. So we have a greater than sign. So that means it is a right, we have a right tail in our distribution. So that means what we need to do is double alpha. So to find the confidence level, this would be 1 minus 2 times alpha. So this would be 1 minus 2 times 0.05, which becomes 1 minus 0.10, which is then 0.90. And that's our confidence level. Okay, so that means when we build our confidence interval, we need to use T interval. So let's go to the calculator, click on T interval, and see what we need to get. So we got to go to stat, test, scroll down to T interval, and luckily list 3 is already there from our hypothesis test, and our confidence level of 0.9 is there as well. So don't need to change anything, just hit calculate, and we get our confidence interval. So 3.43 to 18.13. Okay, so let's go ahead and write down our calculator work and our confidence interval. So data L3, 1, and 0.9. And what we got was 3.43 less than our mean difference, less than 18.13. Okay, so we got two positive values. So positive and positive, if our mean difference is between two positive values, then our mean difference is positive. So since our mean difference is positive, so since our mean difference is positive, that means the cholesterol before is higher than the cholesterol than after. So let me just go ahead and write that final statement. So since the confidence interval is positive, the cholesterol levels before the diet is greater than that after the diet. And that's because when we set up our list one and minus list two, we had before minus after, and we found our confidence interval to be positive. So that means before is greater than after. So that's our reasoning behind that final statement. So our hypothesis test and our confidence interval are saying the same things, that the cholesterol levels are greater than that before the diet. So that's it for the self-check video. Thank you for watching. I'll see you next time. Goodbye.